Hi, welcome back to Mrs. Thompson's classroom. Today we're going to be talking about relations. We're going to be looking at finding their domain and range, sketching the graphs, and finding their intercepts. So before we get started, we want to look at a little vocabulary. So let's talk about what a relation is. A relation is a set of ordered pairs. So basically what we're doing is we're connecting two sets of data. So X, comma, Y. We're tying two things together, okay? So maybe X represents a group of students and Y is their score on a test, okay? The domain is then the set of all first coordinates. That means it's the set of X values, or the input of the relation, okay? The range is the set of all second coordinates, which means it's the set of all Y values, or the output, okay? The input, whatever variable represents the input or the domain set, is referred to as the independent variable. Okay, so like the group of students, or where we start, that's the input. They came in and took the test. The output, or their grades, would be called the dependent variable, because it depends upon what X is, okay? All right, so let's see if we can sketch a few of these. Well, actually, before we sketch them, let's just talk about domain and range. So domain, we said, is the input. So it's the first coordinate, and we're just going to make the set of all of those. So John, David, Matt, and Chris. And I could put them in any order. That's not important. And then the range is the set of the Y values, or the outputs. And so I'm going to write those in a list, and I'm going to put them in order. They're numbers, so I like to list them in order. But you wouldn't have to. It's just a set, okay? Now notice I don't have to repeat either. So let's say John occurred twice in my list of ordered pairs. I wouldn't have to list John twice in my domain, okay? So I'd only have to list the unique values. Okay, let's look at relation P. Now we're just dealing with numbers, but domain is still the X values, or the first coordinates. So 2, 3, 4, 5, and 6. And the range is the outputs. So the 4, the 6, the 8, the 10, and the 12. Okay, now both of these relations are finite. They're just a list of points. There's a finite number of them. But not all relations are finite. Sometimes they're just named as a rule. And so in this case, I would say the relation R is equal to the set of ordered pairs, X comma Y, such that Y is equal to 3X minus 1. That's what this notation means. That's how we would read it. So the domain is the set of X values. In this particular case, I can input any number I want into here, multiply it by 3 and subtract 1. So X is going to be a real number, okay? Or I could simply say negative infinity to infinity if I want to write it in interval notation. The range then is my Y, or my output. Now, if I take any X, multiply it by 3 and subtract 1, Y is also going to be an element of the real number. Y is tied to X, but if I were able to sit here and list all of them, the list would contain every single real number. Okay, so now let's get to the sketching part. So the first thing we're going to do is X is my independent variable, So I can pick any values I like. So I'm just going to pick 5 numbers. Okay, and I like to pick nice ones around 0, just small ones, but I like to get some negative and some positive so we can get a full picture. Then I'm just going to take the rule I was given and calculate y. So I'm going to take my x value and square it and add 2. And after I do that for all of them, I'm going to get a set of points. Okay, so this first one gives me -2, 6. Then I get -1, 3. I get 0, 2, 1, 3, and 2, 6. Then I'm going to go and plot these points. So -2, 6, -1, 3, 0, 2, 1, 3, and 2, 6. Now, because x can be anything I want, I'm now just going to connect these points. This is why it's important that you plot enough points. Now, in future videos, we'll talk about the shapes of some basic relations and functions. So we'll sort of have an idea in our head already, the shape that they're going to form. I also want to make sure when I'm sketching graphs that I label a couple of points, or be sure to label our axes so that anybody looking at this graph would know what it actually says and where the points are, so they could compare their results to yours. So labeling our graphs is important. Okay, one more. So again, we're going to take and just pick our x values, and I'm going to use the same ones I did last time. And I'm going to plug them in. And once I've plugged them all in, then I can plot those points. So -2, 0, -1, -1, 0, -2. I can plot all 4 of those points. Now this is an absolute value function, so I know the shape and absolute value functions are straight lines. So I'm just going to connect these dots as straight as I can. If you've got a ruler or a straight edge, that's great. Okay. And my graph would look like this. Now I said we were sketching, so these don't have to be perfect, but we do want to make sure we label a handful of the points that we plotted and that we get the general shape. Okay, so for absolute values, I would want to make sure that I plotted that turning point there. All right, now the last thing is I said we wanted to talk about intercepts. So there are an intercept is basically an intersection point. So we have x-intercepts and we have y-intercepts. Okay, so x-intercepts are those that intersect the x-axis, and y-intercepts are those where it intersects the y-axis. So on this graph, we have 2 x-intercepts. Okay, so in this case, they are -2, 0, and 2, 0. Okay, in general, x-intercepts are always some number, comma, 0. Because if I'm on the x-axis, the y value will be 0. Okay, then we have our y-intercept is where I'm on the y-axis, so that's this point right here. So that will be 0, -2. And in general, y-intercepts are always 0, comma, some number. Because if I'm on the y-axis, the x value is 0. So we'll do more with our intercepts when we talk about functions in a later video. So you can look for that video coming up on functions. The next video that I'm going to have in this series will be on symmetry. So some of these relations, in fact, the absolute value one I just plotted has symmetry because I could fold it in half, or I could reflect it across a line like a mirror onto itself. So we'll talk about that next time. If you're with me in class, be sure to come ready. We'll talk about this some more, have some question, practice problems. If you're out there on the internet watching this, you can type down below in the comments and I'll see if I can get back to you. So we'll see you next time.